U.S. Army and U.S. Air Force hypersonic weapons are already firing. The Air Force fired off the air-launched rapid response weapon from a B-52. Army is getting ready to field this long-range hypersonic weapon by as soon as next year. And the Navy also has ambitious plans. Hypersonic weapons from destroyers by 2025 and submarines by 2028. But what about hypersonics 10, 20 years from now? That's already on the minds of a group of scientists at the Army Research Laboratory. Through a process called additive manufacturing, teams of scientists look at combinations of different materials to engineer essentially newly manufacture new combinations of polymers, composites, different kinds of metal, in the hopes of uncovering some new material that could perform at a much higher level.
So this is really a processing study, a way to increase develop new ways to manufacture these materials, right? So traditionally, being in a powder process, you really limit the design complexity of the material as well as the complexity of the shape of the part that you can make. So by enabling additive manufacturing of these difficult to manufacture materials, this could greatly reduce cost of the components in the long run, as well as, as I said, kind of increase the design space that we could work with of the internal material. Ceramics have great thermal properties, and that's the reason that ceramics research is of interest for hypersonic applications. But the way additive manufacturing fits in, of course, is because its ability to create complex shapes. This could potentially reduce manufacturing costs, as well as increase the design space of making some of these components.
And they use microscopic analysis, various kinds of assessments to look at the very, very, very small elements of those materials to determine its composition and assess its parameters and its performance specifications with the hope of finding better performing material. Dr. Koo and others look at all kinds of different composite materials, polymers, different kinds of metals, and they additive manufacture them.
So this is a helmet rotating on our industrial X-ray computed tomography system that works very similar to a medical CAT scan, but instead of the source and detector rotating around the patient, we have the sample rotating and our source and detector are fixed. Yeah, so we're getting three-dimensional information non-destructively, and we can evaluate the internal structure of that to then ultimately improve the performance for the soldier.
There are several key ways that different kinds of materials could change the performance of weapons in the future. Something like hypersonics, airflow is extremely critical. The aerodynamics, the shape, the contours, exactly how it's put together can affect its flight path or trajectory. New kinds of shapes are being looked at by Army Research Lab scientists. Also, different kinds of materials have different properties. One of the things about hypersonics is it must be able to maintain thermal management, massive amounts of heat, must be able to sustain its flight, not get thrown off course at extremely high temperatures. Well, different materials have increased ability to do that. Another one is simply speed or penetrating characteristics, different kinds of energetics or explosive properties. All of these things are the future aim of what scientists are looking at now. And it all begins with a microscopic process of looking at different combinations of layered materials, testing them and assessing them, and additive manufacturing. Through that process, they have what Koo called a much greater design space. They're not limited in the kinds of things they can seek to manufacture. So the idea is not only to look for near-term applications of scientific breakthroughs, uncover something of great significance, consequence to concepts of operations or tactical attacks, but to think of kind of warfare and the kind of weapons that might be needed by 2040 and 2050. Chris Osborne, Warrior Maven, the Center for Military Modernization.